In this example, we want to use Euler's method to approximate the solution of the differential equation y prime plus 2y equals t. Then there's a condition y of 0 is 2. Approximate it at t equals 3 using 3 steps with size 1. So to do, we first have to get the y prime by itself. So the way we actually want to write this differential equation is as y prime equals t minus 2y. And I want to work through Euler's method. So we're starting with the value at t equals 0, we have y equals 2. So at this point, the slope is going to be y prime is t, which is 0, minus 2 times y, which is 2, gives me a negative 4. So then my new y value should be the original y, which is 2, minus 4 times the step size, which is 1, which is a negative 2. So my next point will be at t equals 1. And now y equals negative 2. At this point, we have a slope of y prime, which is 1 minus 2 times negative 2, which is 1 plus 4, which is 5. And so my new y value should be negative 2 plus 5 times 1, which is positive 3. So we're at now t equals 2, and now y equals 3. At this point, my slope going to be y prime, which is 2 minus 2 times 3 is again negative 4. So my new y value is going to be 3 minus 4 times 1 is going to be negative 1, which gets us to the point t equals 3, y equals minus 1. So our approximation here is that the value at 3 will be approximately minus 1. Now, because these steps are so large here, there's a very good chance that's off by a fair amount, but it is the approximate that we get from Euler's method for this calculation. In particular, we can actually solve out this differential equation using integrating factors. In this case, our integrating factor is e to the 2t. This over here is e to the 2t y prime. So I then get that e to the 2t times y equals the integral of t e to the 2t dt, which we do by integration by parts. And then we can solve out for y. And if we want y of 0 to be 2, this means we need 2 to equal 0 minus 1/4 plus c. So c is 9/4. And so my solution here is y of t is 1/2 t minus 1/4 plus 9/4 over e to the 2t. And if we plug in t equals 3 here, I get 3/2 minus 1/4 plus 9/4 over e to the 6th, which is not to about 1.255. So we're not very close, right? This value is fairly different from the minus 1 we got up here. That's because of the large steps. If we take a smaller step size, we'll get something that's more accurate to the solution when we use Euler's method.